Okay, everyone. So you can now join in Slido. So you can either scan the QR code, or you can go to slido.com and enter the code. Here's the first question that you're going to get. And so 1 essentially means that you think Cardano is the biggest scam ever. 2 means that you're like, slightly negative. 3, neutral. 4, slightly positive vibes. 5, you think this is the best thing that's ever happened to humanity. Okay, exaggeration, obviously, but still. And usually it's usually last time when we were here, we had a very nice normal distribution. So I'm expecting something similar. Yeah, you can still fill it in, I think, even if I keep going. So we're tight on time because we have a lot to talk about. So I'll just get right into the intro. But we will be talking about first, second, and third generation soon, and also compare Cardano with some other layer 1s. So what is Bitcoin? Well, to give a bit of context, we have to consider the 2008 or 9 financial crisis. A lot of people saw the bailout of Lehman Brothers as the evidence that the financial system of the world isn't working for the normal people, it's working for the elites. The rich got bailed out, whereas the hundreds of thousands of homeowners, lost their houses. Only one of the financial, like Wall Street elites, were put in jail. Most of them actually came out even wealthier than they were before. So that sparked things such as the Occupy Wall Street movement. But some argue also that it led to the creation of Bitcoin. So it was a new way, and the first time you actually had a way of transacting money peer-to-peer on a global scale without needing to trust an intermediary. Because if I send money now through PayPal, I'm trusting PayPal. Someone is keeping track of the ledger or of like who owns what. In the first transaction of Bitcoin, the following reference was written, and this is a reference to the UK. It was a UK official that considered a second bailout. So all of this is just to illustrate a bit of the ethos. It's about getting away from these financial institutions. It's about having ownership over your own currency and not needing to trust anyone. So with that said, Wanxing, it's up to you. I actually didn't present myself. So my name is Simon Sellström. I'm a second-year MPhil student in economics. And I essentially got into Cardano just 2021 January. But no, let's go on. You can use this. Press this.
Yeah, so hi everyone, my name is Wanxing and I'm a first-year undergrad human scientist at Harris Manchester College. And now I'll be explaining to you how Bitcoin works and also what is blockchain technology. So first of all, what is money? As you can see here, all these are considered money at one point of human history, right? And money essentially is just a medium of exchange. And the best way to understand Bitcoin is using the Yap Island stone money analogy. So this Yap Island is actually a tiny island on the Western Pacific Ocean. And on this island, the island people actually use this large stone disc in front of their houses as money. So you may wonder, like, how can this large, heavy stone disc be considered as money, right? Shouldn't money be portable? Shouldn't we be able to exchange it, easily pass it to another person? And the reason why they can use this is because the island people, since they know each other, they maintain a robust oral ledger of who owns what. This means that if I want to buy 10 fish from Simon over there, I will just tell him that, hey, Simon, I will buy 10 fish from you in exchange for the rye in front of my house. And once we have reached an agreement on this, we will tell the rest of the community that in exchange for 10 fish, the rye in front of my house is now his. And once everyone agrees, the transaction would have gone through in a modern sense. And how is this related to Bitcoin? So for Bitcoin, it works like Bitcoin is a network. So just like just like Yap Island is a community, Bitcoin is a network of participants. And just like how on the Yap Island, like everyone maintains a mental record of who owns what, everyone in the network on Bitcoin actually has a spreadsheet, a digital ledger of all the transactions that has ever occurred on the network. And lastly, just like how the transaction on Yap Island will only have gone through if the rest of the community agrees that it did happen. So it's the same case in Bitcoin network. Like the rest of the community, the rest of the network must agree that this did happen. They must add it to their copies of the spreadsheet, right? And so let's talk about the evolution of trust, because trust is necessary for a currency to function. So in the Yap Island's case, the trust is social in nature, because community members actually know one another, and there are social repercussions for lying, right? So, but it's not feasible to be used in a societal sense in a large scale. And the way we solved it right now is through institutional trust, where everyone trusts the central bank. So I can buy coffee from some coffee vendor that I've never met before in my life, and this transaction will go through because we all trust that, like in the central bank, and the coffee vendor knows that the money he gets will be able to be used elsewhere afterwards. And Bitcoin is the next iteration of this evolution. So the trust in Bitcoin is actually digital in nature. So what this means is that people trust the code. And this actually brings together the best of both worlds, because just like in the case of the modern economy, it can be operated at a large scale, but at the same time, we don't have to trust any institution. All we need to do is to trust the code. And the reason why we can trust the code is because of blockchain technology that underlies it. So Bitcoin is actually the first generation blockchain. And to understand blockchain, we must understand it from two fronts. First of all, blockchain as a data structure, and secondly, blockchain as a network. So as a data structure, blockchain is literally just a chain of blocks that contains data of transactions, right? And these chains of blocks are linked together using cryptographic hash functions. And although I won't be going into details of this today, but what this essentially means is that, say, block one was created like 5 days ago, block 2 is 3 days ago, and block 3 is yesterday. And what this means is that if I try to change something in block 1, it will immediately invalidate block 2 and 3. And everyone on the network can see that this has been tampered with. So I will be skipping this part. If you are interested, I can just explain to you afterwards. Yeah. And so let's recall this diagram just now. Bitcoin is a network. So it's what this means is that, like, okay, recall that we mentioned just now that everyone on the network actually holds an entire copy of the entire ledger. So in the same case, okay, in the same way, like the ledger, like I'm mentioning just now, is actually blockchain's copies. So everyone holds an entire copy of the blockchain, right? So what this means is that like when a transaction has already gone through in the blockchain in like 5 days ago, it's impossible to change it, because first of all, once you change something in your copy of the blockchain, it will make it obvious, very obvious to the rest of the network that your copy has been tampered with, right? And secondly, is that you have to somehow convince more than 50% of the entire network that your copy, of the blockchain is the single version of the truth, whereas like theirs are wrong, which is almost impossible, especially if the network are like especially if the network is very, very large. All right, so that is for changing why blockchain is immutable, not be whatever you throw in can't be changed afterwards. So what about adding new transactions to the blockchain? So how does the network of untrusting participants in this global network, how does the participants in this untrusting network decide on what exactly should we add to the network next? And they need to reach a consensus, meaning that more than 50% of the network participants must actually agree to add it to add this transaction to their copies of the blockchain. And this is pretty complicated, but let me try to run it down really simply. So have you all ever heard of the term? Have you ever heard of like the claim that Bitcoin is using a lot of energy, like consume a lot of electricity? Yes. And the reason why it consumes a lot of electricity is because of this thing called a proof of work. So remember just now we mentioned that we need 51% of the entire network to agree such that the new transaction can be added to the blockchain. And like because it is a digital network with untrusting third parties, so we can't actually create new accounts and vote by the accounts because it's inexpensive to create a new account. And in this case, like Gloria can try to create 2 other accounts of herself. And if the voting is done by like the number of accounts that you have, voting power is tagged to the accounts, then you will effectively have more than 50% of the entire network, and she can force through some malicious transaction that shouldn't have gone through. So how proof of work works is that instead of tying voting power of the individuals to the accounts, to the identities that they have, they're tying it to the computational power instead. So in this case, even though Gloria has created 3 accounts, she only effectively has 1 unit of computational power. So what this means is that she only has 1 vote in this network, and she only has 33% of the entire network. So she cannot force through malicious transaction. The rest of the network doesn't agree to it, right? And although you may wonder, like, although you may just say that, what if Gloria has 3 computers, right? But this, in this case, it might work for her. But imagine, like, if there's a large network, then she needs to have, then she won't actually, then she needs far more than 3 computers to actually attack the network. Okay, so in general, let's sum up. Blockchain is a network of participants, each of whom holds an immutable copy of the entire history of transactions, meaning that whatever that's added in the past can't be changed afterwards. That is transparent in the case of public blockchains for all to see, and where new transactions only have gone through if the rest of the network reaches a consensus. So here, a thing to note here is that blockchain is not the same as cryptocurrency, whereas cryptocurrency is the coin on the blockchain network. Like blockchain itself is the infrastructure that underlies it. It's a technology. So even though there are a lot of claims that that blockchain and Bitcoin, everything, they're all speculative assets, they're environmentally damaging. That may be true, but the blockchain technology that underlies it is very sound and secure. All right, so now I'll be passing on the time to Taylor.
Hi, I'm Taylor. I'm a 3rd-year physicist at St. Hugh's, and I'm going to talk about the different blockchain generations. So Bitcoin can be thought of as the 1st generation of blockchains. It was designed for the specific use case of just being a medium of exchange or peer-to-peer electronic cash. Ethereum, a 2nd generation blockchain, was designed to extend the functionality of the blockchain by the addition of smart contracts. And this allows for applications such as decentralized finance and NFTs, which I'll explain in later slides. So first, what is a smart contract? A smart contract is like a traditional contract. However, it's a digital and not on the blockchain. This means it preserves the properties of the blockchain, such as deterministic execution, trustlessness, and the efficiency. So this means that once the conditions for the contract has been met, it will automatically execute, and the transaction cannot be easily reversed without the network being attacked. And you don't have to rely on a 3rd party for it to execute. As long as most of the validators are honest, the contract will go through. So an example of how a smart contract can be used is in crop insurance. So let's say the farmer Bob is worried about his crops dying from the temperature being too high. He can agree with the insurance company that if the temperature is above 36 degrees for 4 days of the year, the insurance company will pay him $10,000. And in return for that, if those conditions are not met, he'll pay them $2,000. So why do this with a smart contract? So Bob does not have to rely on the insurance company or the auditors of the insurance company for the transaction to go through. Simply £10,000 from the insurance company will get locked in the smart contract, and he'll lock in 2,000. And once the conditions have been met by a data feed known as an oracle, the smart contract will get executed. So let's say the temperature is above 36 degrees for 4 days of the year. Bob will automatically get his £10,000. This saves time for Bob because it means he doesn't have to file a claim with the insurance company. And it also saves time for the insurer, since Bob will automatically give them the money if the temperature is not above 36 degrees for 4 days of the year. Wait, that was my skip. Okay. I'm not going to talk about that slide. Okay, so another application of smart contracts is NFTs, or non-fungible tokens. Non-fungible simply means that the item is unique. For example, any piece of artwork is not exactly the same as another piece of artwork. Whereas a fungible token would be something like Bitcoin, because any two Bitcoins are indistinguishable. So one very popular use of NFTs recently has been in the art space. So let's say you want to buy a traditional piece of art. You have to drive to an art gallery. They'll have maybe a limited number of pieces of art. And you go to, let's say you find a piece you like and you go to buy it. And then the seller gives you some price. Now, you don't necessarily have any way of knowing if that price is good relative to other sellers. You also ask them, how do I know if this art piece is legitimate? And maybe they'll give you a signature, but you have no way of verifying if that is legitimate. Whereas a non-fungible token, you can check on the blockchain who the recent buyers and sellers are. You can also compare it to other similar pieces of art to see if the price you're getting is good. And you can also tell who produced the piece of art. But why would anyone want to buy an NFT art when you can just copy and paste it? I think the main reason is people want to feel part of a community. So one popular community is the Bored Ape Yacht Club, represented on the right. People also want to have their own form of digital ownership. And beyond simply artwork, another use of NFTs has been from the famous entrepreneur Gary Vaynerchuk, who created NFTs called VFriends, which can be used as a ticket for his event VCon. And the advantage of this is that, let's say you find out, oh no, I can't go to the event. You can easily transact on the blockchain and sell your ticket. This means it's both easier for the initial seller to sell the tickets, because people who don't know if they can buy know they'll be able to sell it on in the future. So another use of smart contracts is in decentralized finance, or DeFi for short. So the idea of decentralized finance is to build a trust minimized financial system that is more efficient and transparent than the legacy financial system. So current financial infrastructure, such as lending and borrowing, insurance, and payments, have already been created via this method. So one key example of this is in stablecoins, where a stablecoin is simply a crypto asset pegged one-to-one to a fiat currency, often the US dollar, and you can use it to transact overseas at any time of day, and you can transact large amounts of money for a relatively low price. Whereas traditional financial infrastructure may not be able to transact on the weekends or in certain jurisdictions. And one prominent country that has used this recently is Meta. So now I'm going to hand over to Lucy.
Great. So hi, my name is Lucy. I'm a first-year undergrad doing math. So now we're finally move on to third generation blockchain, and more specifically Cardano. So just for some fun, if you can join the Slido by entering that code or scanning QR code, that would be great. Okay. So, approximately how much energy does a Bitcoin transaction consume? Is it 0.5K watt hour or 10, 500,000? Okay, we have some variety here. It's actually 10,000. I mean, it's actually 1,000K, 1,000 kilowatt hours. So it's like a huge amount. And well, approximately how much energy does a transaction on Ethereum consume? Nice guess. And finally, approximately how much energy does a transaction on Cardano consume? Yeah, in fact, Cardano only consumes 0.5 kilowatt hour per transaction, which comparing to Bitcoin and Ethereum is a much lower. So we're going to talk about how Cardano is able to achieve this. And before that, we'll just talk about third generation blockchains. So what motivates the third generation blockchain? Well, it's here to solve the problems faced by the first and second generation. And that is, say, the first generation is Bitcoin and second generation is Ethereum. So the first thing the third generation blockchain aims to solve is scalability. On Ethereum, you can make 12 to 15 transactions per second, and the transaction fee are $20 and sometimes up to $200 per transaction. And people are not gonna want to transact on want to use a cryptocurrency if they are spending such a high fee. Say if you're just buying something for $50 and then you need to spend $20 transaction fee, you will not want to do it. So what third generation blockchain is that it wants to actually be able to carry out a large number of transactions per second. And next is the problem with sustainability. As we saw just now, the first and second generation blockchain use proof of work, which use a huge amount of energy. And that is environmentally unsustainable because people are just competing in terms of computational power, which requires energy. And at the same time, we also need to think about the sustainability of the blockchain technology. How do we ensure that this technology develop and evolve over time? So what we have in terms of sustainability, we want third generation blockchain want to achieve environmental sustainability by consuming less energy and also sustainable on-chain governance. So what this does is that through decentralization, holders of the cryptocurrency built on the blockchain are actually able to decide where the blockchain is going next, how the technology of the blockchain is going to develop in the future. And last of all is interoperability. It is how blockchains are able to interact with each other and how it interacts with the traditional financial system. So the problem we have with first and second generation blockchain is that, first of all, there's a limited transaction per second. As we can see, for Bitcoin, it's 7 transactions. For Ethereum, it's 12 to 15 transactions. And for reference, Visa actually has 24,000 transactions per second. And also huge energy usage. Several thousand gigawatts. It's sort of comparable to the energy used by a small country in a whole year. So why does it have such high computation, such high energy cost? First of all, computational power is needed to validate transaction, and bandwidth is needed. Of those require energy as well as storage, because we need to store transaction data. So what Cardano is that it has Ouroboros, is the consensus protocol on Cardano. And what it enables Cardano to do is that it can process 250 transactions per second. And also with Cardano, for one transaction, you can actually send money to multiple addresses, as well as a quite low energy usage. So what is Ouroboros? Arbolus is actually a proof of stake, consensus protocol on Cardano. And the consensus protocol is a law that governs the behavior of blockchain. For example, it says how one can validate a transaction and create block and add them to the blockchain. The proof of stake is an alternative to proof of work, which we briefly mentioned just now. So on Cardano, the cryptocurrency is called ADA. So what we do on Cardano is that users stake ADA in a stake pool. Stake pools are server nodes which ADA holders can delegate their stake so that everyone can participate in the protocol. So a stake pool is essentially computers that run the code and validate the transaction. And here what we have stake pool is that even if someone don't have the technological ability or the hardware ability to run a node to actually add blocks to the blockchain, they are actually able to participate in the activity of the blockchain by staking. And then Cardano network will choose a stake pool as a slot leader. This process is random. There's a randomized function to do this, and it also depends on how much stake the stake pool has. So if you have a higher stake, there's a greater chance for you to be chosen as the slot leader. And then this stake pool will add a new block to the blockchain and also earns an award, which is the transaction fee of the transaction it verified. So why do we want proof of stake, or how does it compare with proof of work? First of all, proof of stake is more energy efficient because people are competing in terms of stake, in terms of how much cryptocurrency you own, instead of competing computational power. And also it reduces computational work because once one block is only verified by a limited number of nodes instead of everyone on the blockchain trying to run the same node and see who gets it first. It's scalable because it's consumed less computational power. We have sort of more computational power in general to process more transactions. And also there's less incentive to attack because you are you are staking the ADA you hold to exchange for the opportunity to add the block. And if you don't successfully add the block, you actually lose those money that you stake in. And in terms of 51% attack on proof of stake, you will have to own 51% of the cryptocurrency, in this case ADA, in order to carry out a 51% attack, which is generally very, very difficult. And next one, I'm going to talk about this unspent transaction output, known as UTXO in short. So this is how proof of stake prevents double spend. Say now Alice needs to pay Bob 25 ADA, and Alice has 2 UTXO, one with 20 ADA, one with 10 ADA. So what she needs to do is that she needs to put both of her UTXOs into this transaction, and then in terms of output, Bob will get 25 ADA and 5 ADA will go back to Alice. So in the end, Alice has 5 ADA of UTXO, and then Bob has 25 ADA UTXO. And in terms of, and then in one transaction, the total input must equal total output. So when you know that they're not equal, for example, you have more output than input, then some money is created out of thin air, which possibly this person is trying to double spend, and they're not going to allow that. Or when input is less than output, when input is more than output, some money just disappeared, which is also not making any sense. So this makes transaction actually computational easy to verify whether there is a double spend or not. And then we'll talk about more design philosophy of Cardano, which
Okay, I'm now going to talk about Cardano's design philosophy and what it sets it apart from other blockchains. So to start with, I'm going to talk about the blockchain trilemma, which was first proposed by Vitalik Buterin. And the blockchain trilemma is basically the fact that decentralization, security, and scalability are, you cannot achieve them with a simple blockchain architecture. For example, Bitcoin and the current iteration of Ethereum both achieve security and decentralization. So they have low throughput, which is what leads to the very high fees. Other blockchains, such as Solana and Binance Chain, compromised on decentralization in order to achieve greater scalability. However, Cardano believes that to have a global sustainable blockchain, you need to solve all three of these problems. The process Cardano went through was peer review, where papers for protocols would get reviewed by leading experts in their field. Cardano used the conference-based peer review system in order to, as opposed to the journal-based peer review system, in order to iterate faster and have greater innovation. And the reason they chose a peer review-based system is in order to build a solid foundation where they can iterate off, because it's very difficult to change a protocol once applications have been built on top of it. Further, as part of their security, they chose the programming language Haskell, which is a functional programming language, differing from Ethereum Solidity, which is an object-oriented programming language. The reason for choosing a functional programming language was because it is easier to verify the smart contract execution. And this was motivated by the some 12 billion or so in hacks and scams that have been lost from smart contracts. To further enhance security, Cardano partnered with runtime verification to bring K-semantics to the blockchain. K-semantics is essentially a way to verify the output of a smart contract or virtual machine. And this allows developers to understand the smart contract execution, enhancing security. To aid in decentralization and security, Cardano's novel proof of stake mechanism, Ouroboros proof of stake, utilizes what's known as a Nakamoto consensus, as opposed to ETH 2.0 proposed Byzantine fault tolerance. Without going into the technical details, one of the key advantages of this is that the Cardano consensus does not require slashing. Slashing simply being if a malicious actor tries to subvert the network, they would lose a portion of their staked assets. Cardano consensus does not require this, and this encourages greater staking because people know they are not as likely to lose their ADA if the person they delegate to acts maliciously. Furthermore, their staking allows for what's known as liquid democracy, which even after you've staked your ADA, you can still lock it up in smart contracts to earn further yield. This had led to a very high percentage of ADA staked, roughly around 70%, enhancing the security. Also, to prevent people allocating too much to one pool, Cardano came up with the K parameter, which essentially means once you reach a certain amount of ADA delegated to a certain stake pool, the rewards begin to drop off as ADA delegation increases. This encourages people to delegate to smaller pools, enhancing decentralization, since they will get a greater percentage reward. To further decentralization, Cardano has made it especially easy to run a node on the blockchain. Whereas most blockchains, it's very difficult to download a full copy. You can easily do this on Cardano via the Daedalus wallet, and you can simply run a full node using a Raspberry Pi. This allows for more people to run a node, which is what enhances decentralization. As part of its scalability efforts, they came up with a novel smart contract method, which is the EUTXO. The EUTXO contrasts from other blockchains' account-based models, since it has a local state, whereas an account-based model has what's known as a global state. The problem with a global state is that transactions can fail even after you have paid the validators for a transaction, since certain transactions before that can interfere with another, invalidating transactions you've already paid for. Whereas the local state of the EUTXO allows for deterministic fees. The local state also has a smaller surface area of attack because you do not need to consider how different participants interact with a smart contract, enhancing security. This local state also allows for greater parallel execution of transactions and potentially makes it easier to shard the blockchain, where sharding is simply a way of splitting up transactions on the blockchain and only having certain validators validate them, as opposed to the whole pool of validators validating any one blockchain. And this allows for greater throughput. Now I'm going to hand over to Simon.
Okay, so we'll talk now a bit more about real world use cases. But before that, go back to Slido and think a little bit about some use cases that you can think of smart contracts or just blockchain. Oh, yes, supply chain. That's a good one. Elections. Okay. So anything really, like blockchain is really about solving problems where you have multiple actors that do not trust each other. That's one kind of way of thinking about it. Another one is to think about the smart contract execution, like removing the need for someone who's checking conditions and then saying, okay, if these are satisfied, then that happens. Data access managers, DAO governance. Okay, cool. I thought about some of these. So the first one is the identity, supply chain track and trace. A challenge in the status quo is that if you buy a product that's and it says that this is sustainably produced, or let's say you buy a shoe from Adidas or Nike, they actually don't really know where all of these source materials come from. So it's really difficult to actually make sure that no child labor was involved, or it was environmentally produced, or even if they actually claim that it was, there's no way for you as a consumer or even as some government regulator to check it. With blockchain, you can add each item, each component of this whatever shoe, you can add a time-stamped and GPS sort of geolocated piece of information. You can add that to the blockchain. And so it just becomes a more convenient data access, data management structure. So then you can you have a transactional history. So as you move an item as well, you can kind of see, oh, well, it got shipped to the dock and now it is moved to the store. So you have all of these different people throughout the supply chain. Next one, well, I think this is the most obvious one. So I for example, I bought a secondhand watch, but I have no idea if that is authentic. It was actually produced by the brand that claimed that it was supposed to be from. So by blockchain in the future, if we all use blockchain, you would be selling something like used or secondhand on Gumtree or on Facebook. But as you sell it, you would also transact the NFT, or like the digital representation of the item, to whoever you're selling it to. And this person can then check if this NFT was issued by, for example, Apple. Let's say I'm selling my Apple computer. Apple would then have a public key that everyone kind of knows. So you can see all of the Apple products that's ever been made. And then you can kind of track that specific MacBook. You can track it and see, okay, it went here, it went here, it went here. And now whoever person has this and is sending it to me. And that way I'll be able to know if a watch is a real one or whatever I'm buying. So that's quite a good benefit. Another one is voting, as someone mentioned. So one of the things with digital voting, one of the reasons why it's kind of difficult to do well, is because it's hard to make it both secure and not corruptible. So one issue is that, for example, you have the obvious one, which is just malfunctioning. It's just not working very well. But you also have the problem of some single entity being able to kind of tamper with the numbers, because ultimately it's quite easy, right, to just change a number in a spreadsheet if it's electronic. It's a bit harder to change physical ballots. what changes with blockchain specifically, and not like other digital technologies, is that if you have, well, you have to imagine that you have a private key. So we haven't talked much about that, but the private key is essentially your signature. And that is the foundation of Bitcoin. Like in voting systems that are blockchain based, every ballot would have to be signed by a specific person. And on top of this, you would also have to say that, well, these are the sort of keys that are eligible to vote. There are a bit of fancy things involved in that, and specifically something called zero knowledge proofs. Using so-called zero knowledge proofs and blockchain technology, you would be able to independently verify that your vote was counted. So in the case of the US election, people say, well, I don't know what happened, there's a lot of cheating. Well, if you don't trust the system, in this future, you could check yourself. Your vote was counted, there was no cheating, you can see all the votes, they all have like signatures that are linked to someone who is a citizen and is alive, for example. So, and I guess just to mention, zero knowledge proofs are proofs where you can prove a property of something, but without showing like the full information. So that could be, for example, if I might want to prove that I'm above 18, but I don't want to show the bouncer at the bar exactly when my birthday is or exactly how old I am. So a zero knowledge proof is quite a new thing. It's from the last, I think it's like 5, 10, 15 years at most, that's been emerging. But it's only like in the past few years that it's really it's accelerated. And then here, charitable donations. So, well, if you think about Afghanistan, one of the things that happened when the US troops pulled out was they realized that, well, where did the money go? They had sent a lot of donations, a lot of fund to Afghan troops, but they didn't really know where the money ended up. And there were claims that, well, the Afghan military needed to pay 200 soldiers. In fact, there weren't 200 soldiers, there were like 50. But more generally, you can think of other charitable causes where you don't really know where the money's going. Is it going to some corrupt local politician, or is it going straight to the people who are the intended recipients? So with charitable donations, you kind of get the full transparency. You see all the transactions. Obviously, you still need to add something more than that. You need a digital identity, because right now, if you send a transaction on Bitcoin, it's just to an alphanumeric string. It's like an email address. It says like 1, 2, 3, 4 ABC. So it's a bit anonymous, but if you add digital identity to that, well, then you get the benefits of transparency. So now Adaku will talk about how to get involved, things you can do. And then after that, we'll have a short quiz.
Hey everyone, my name is Adaku. My first degree is actually in economics, and I did a master's in marketing and my PhD in entrepreneurship and wellbeing and digital economy, then master's in health economics. So yeah, I'm really interested in this space for different reasons. But anyway, here's how to get involved with Cardano. I'm going to start off with Project Catalyst, which is essentially a series of quarterly funds taken from the Cardano treasury, where essentially anyone can make a proposal for Cardano related projects. And it's essentially a proposal that addresses a challenge, and there's different challenges per fund. Also, anyone can become some kind of community advisor, which I'll explain soon. And this is essentially where you just write reviews for the proposals, which I mentioned. And other ways of participating is by joining the challenge team, being a voter, a referrer, or a veteran community advisor. So there's quite a few example proposals that you can see right now. Obviously, we know the best thing about blockchain is that everything is freely available. For example, direct ed, which is direct donation for education, research service, Oxford Student Hub, which is what we're doing right now. So presenting Cardano with Oxford University as a group of us there. And I mentioned direct ed already. I put this out to show you that these are some proposals that weren't actually funded, but with regards to like women in STEM and women in Cardano, even though some of these weren't funded, what they do tend to do is create community, and I'll speak about community in a second. But you can even just see the little icons, people sort of celebrating some of these ideas, and each proposal tends to have comments and obviously a review stage, so the proposal will at least get some feedback. But it's a great way to network too, because sometimes you'll see in the comments, people will be like, oh, I'd love to join this project for next time. And they can always submit again. So I mentioned community advisor earlier. Why become a community advisor? So actually, I'll reiterate what it is. The community advisor is an opportunity to review project catalyst proposals, and essentially anyone here can be a community advisor. You essentially just read the proposal, which varies in length, and you get paid to do so. So you can get a good review. Your review can be classed as good, and you'll get $60 for that, or it can be classed as excellent, you'll get $180 for that. The sign up is really quick and easy, and it's accessible to all right now. So it's a really great opportunity to make money, but to also be involved in the community, because by reading these proposals, you just learn more about what is potentially going to go on for the future of Cardano. Whether the proposal you reviewed was funded or not, it's still quite interesting to see what people are submitting. So here's a timeline for the Fund 8 just finished, so next Fund 9 is coming soon. And here's a quick timeline, but we will definitely do another event soon, more specifically on community advising, so look out for that. Things to note as a CA, so assessments have to be independent. It's a bit like if you were assessing someone's coursework, like you wouldn't just give the same review to everyone. So there are systems in place to identify when reviews are too similar, understandably so. And you assess in 3 metrics: impact, feasibility, and auditability. And it's actually quite straightforward. The more you do it, the easier it becomes. There's guides available. We've got a team here who's done lots of reviewing before, so we can also help with that when we do that event. And practical steps that you can do right now, how to get involved. They've got a Discord channel where the QR codes come in too, so you can join our Discord channel. You can create a Cardano wallet. CC Vault, for example, is a good one you can get. You can go on cardano.ideascale.com and create an account to get ready to be a community advisor. We can speak about that in more in depth another time. As I mentioned, there's a community advisor guide, which is very useful and helps you make your reviews. A key note to make sure you put the Cardano address when working with ADA and not MetaMask, because obviously it's different to ETH. And yeah, so key for tip of your assessments, again, we'll go more specifically into community advising when the time comes a bit closer. Another great opportunity that you can get involved in right now is to write short articles which we publish on Medium. So we actually got some funding in the most recent round, Fund 8, so we're able to fund some writing of articles, and these can be on anything that we mentioned today, for example. And it's a great opportunity to learn more about cryptography in general, game theory, economics, and just Cardano more so, because as you're writing, as we all know, as you're writing, you have to research and learn more. Really decent pay, $23 an hour, and you get them published in Medium, which you can put in your CV too. So as I mentioned, we won a little award from Fund 8. Another great opportunity to join the SUM scholarship program. So you can learn how to develop on Cardano blockchain, languages including Pluto's Cardano's native smart contract language based on Haskell, which we've mentioned a lot today. The scholarship program will be self-paced and approximately 10 weeks started from mid-July. There'll be 9 scholarships of $500 each, and also a group-based final project presentation at the end of the course term. Why apply and learn Pluto? So your eyes might have been drawn straight to the second paragraph, but there's great prospects, job prospects within Cardano, and the pay is very good too. So you can make anything up from $70 to $100 an hour, and or 130K to 190K a year. So it's definitely worth applying for our summer scholarship program. And if not, there are good job prospects elsewhere with Haskell function programming in finance, such as Barclays, Facebook, Twitter. Here's just a quick example. Lucy mentioned earlier about Cardano stakes, but there's several ways to get involved with Cardano, and one of them, when you make a wallet like Yoran, you can choose to sign up to a stake, like a mission-driven stake pool in Cardano ecosystem. An example of that is the 21 ADA, which is run by a woman, and 20% of profits go to building a water well in Ethiopia. So there's so many opportunities to just really immerse yourself in the community. As I mentioned before, here's the QR code to our Discord. And also there's some other cool Discord groups to join too, like Cardano for Climate, Women of Cardano. And if you sign up to ours, I can send you the link to the others too. We'll leave the QR code on a bit later anyway. So quick summary, I think we mentioned so far. So the Cardano blockchain protocol, so it's an environmentally sustainable blockchain emphasizing security, decentralization, and it's very mission driven. So we didn't mention it too much today, but Cardano does a lot in Africa, so across Africa, and it's one of the most mission driven blockchains out there. So yeah, hope you enjoyed the presentation. There's a quiz now, so go back to the slides and we'll get. Okay, when you're ready. So what is the name of the creator of Bitcoin? Well done. You got it right, yeah. This is huge. Next, oh, I'll leave the board here. Well done, the top 5. But don't lose hope. It's a great way to learn. So Cardano's data cryptocurrency is named after the first female programmer whose first name is Ada, but what is her last name? Well done, lovely. Coincidentally, my name's Adaku, but the first 3 letters are the same. Okay, next. What makes you most interested in Cardano, especially perhaps after this presentation? Interesting, environmentally sustainable, scientific rigor. Cool, yeah. Okay. What was the most important thing that made you come today? Free food, there's always the one or two. No, to learn more about Cardano is good. Okay. What was the second most important thing that made you come today? No, okay. So hopefully you learn a bit more about the blockchain too. Will you be applying for the scholarship? Nice, good to know. Okay. Congratulations, Dee. And thank you so much. So on a scale of 1 to 5, what's your impression of Cardano right now post event? Cool. That's nice. Okay. Thank you so much. This is our QR code to our Discord. I'll leave it up here in case you want to scan it and join our group. Should have food coming very soon. Yeah. Yeah, but if anyone has any questions, please feel free to ask anyone of us now. We can try to answer.
Yes, question.
Just one thing just kind of get on my head. I got an email for this. It was saying L2, this is L1 here. Just one detail. Just takes.
Oh, yeah.
So here, the Bitcoin requirement is 150 gig, and the node is 190 gig. So it's like 500 gigs. Just so I'm running my own nodes, so like I know.
Yeah, that's good. That's good.
Just saying. I don't know about the other one blockchains because I'm just running Bitcoin only. And I have my questions in that. So I just
Okay.
out of the way, something about it. My question is, as you pointed out that there are the so-called level 2 and level 3 blockchains, and they are faster, more efficient, right? But you didn't mention Bitcoin's Lightning network, which is a lot faster and is based on a lot more sound blockchain.
Mm.
So
Yes, it's good that you mentioned it because there's something called Hydra within the Cardano ecosystem that is very much based on the Lightning Network technologies. Except they did a bit more research. They published a paper, or I don't know if it's published yet actually, but they've written a paper on it, and it uses, since Bitcoin is a UTXO based model, Cardano is also UTXO based, so naturally there are going to be a bit of like inspiration taken from there. So I wouldn't say that. I mean, in terms, well, I don't know what your question was really, but I just wanted to comment that yeah, there are a lot of overlaps, and I think there are a lot of like, I think I would see at least Cardano as the sort of proof of stake version of Bitcoin because of the, I guess, UTXO and the emphasis on the values, I guess, and decentralization. But do you have a question actually?
my question was kind of because like the next generation blockchains imply that you need faster, more scalable transactions, but Lightning literally solves that issue, right? But I do understand that if you want to make blockchain Turing complete, you need those faster transactions. Therefore, the layer 1 or base layer needs to be also faster. Right? My question was, why did you mention that? So, like,
Oh, yeah, there are a lot of things that we didn't mention. So it's just really hard to pack in everything. I think I don't know that much about Bitcoin, like the Lightning Network, but apparently it's I mean, it has its problems, so to speak, and it was peaking a few years ago in terms of like they had traction and it were kind of growing, whereas I mean, please correct me if I'm wrong, it's not sort of accelerating, at least now. But I mean, I'm glad if the Lightning Network is going to work. That would be ideal. And yeah, question there.
You talked a lot about all the benefits of Cardano. What would you say is its biggest problem?
Yes, that's a good question. We have slides on that as well, but we were afraid of not making it through it. But I guess, yeah, let's just keep it. So in short, it has to do with, well, one of them is scalability, so the transactions per second. So if you're actually going to get to 40,000 competing with Visa, well, then you have to do something, you have to figure out something else other than just using the 250 that currently is the transactions per second. And one of those methods is Hydra. So, and as I mentioned, Hydra refers to this mythological creature that has a lot of heads, and the way it will work is essentially that you well, actually, I'll just say that's their way of trying to solve it in terms of increasing transaction per second. But you know, it hasn't been done, so I'm not sure. I think that's, so scalability is one issue, and then another one, I guess, is interoperability. So being able to talk with a lot of different blockchains and communicate. I would say that that's a bit, it's unclear how that's going to work in a secure way. Some other things, I don't know.
Yeah, I guess in general too, there's a lot more to build, a lot more to do. And I think that's where Project Catalyst comes in, because it's an opportunity to get people thinking about, okay, where are the gaps and what else can we do? And even considering like things being multi-chain in the future, the different wallets and everything, there's a lot more that can be done. So yeah, I mentioned Project Catalyst, and if you go on the website, you'll see essentially it's like saying, okay, yeah, here are all the things you still need to do. So yeah, get in there.
And I guess the last thing is the fact that they're using a functional programming language as on the sort of, basic level, or for the basic protocol. That makes it quite inaccessible, or it's a bit like it's a high barrier to entry. But they do so for good reason. But that also, well, the consequence is that it's going to be harder to find developers. It's going to just not going to be as you're not going to have as many people who can actually develop fully. So, but right now there are a lot of products, a lot of projects being built. So up, I think the latest number I saw was 900 various projects, which is quite a lot. One critique generally has been that Cardano doesn't have many projects or apps. And that's because they only got smart contracts a few months ago or so, well, half a year ago. And it's still sort of active in terms of actively being developed. So as you might have seen in the fact sheet, it is the most actively developed core protocol overall. You can always look at different metrics, but at least according to you know, one such metrics, I think there is like GitHub commits. It's being the most actively developed. And with that said, I wonder. Yes. With that said, we are out of time, but we're gonna have some food. Munching is there food ready actually? Yeah, check food is outside, but it should be right outside. And please ask more questions. I mean, we're gonna be around. We'll sit outside and just chat a bit. And, yeah.
Thank you.